Alright, our I can statement for today is, follow along, I can use parallelograms to derive the formula for the area of a triangle. And derive, remember, means to find or to develop the formula for a triangle, the area of a triangle. Now, in a previous lesson, we used rectangles to find the formula for the area of a right triangle. So I'm going to quickly review that lesson so you remember it. We know that the formula for the area of a rectangle is area equals base times height. We also know that if we cut this rectangle diagonally, we will get two right triangles. And these triangles will have half of the total area of the rectangle. You can see that this is half of the rectangle, and this is half of the rectangle. So, if that's true, we know that the area for a right triangle is half of the base times the height, because it is half of the rectangle, and the rectangle was base times height. Another way to think about that is base times height divided by 2. Now let's look down at these next triangles. These are not right triangles. The first one is an acute triangle, and the second one is obtuse. Now if we draw the exact same triangle again and match it up with this triangle, let's see what kind of shape we get. Here's the exact same triangle, so I'm going to match up the same sides. So this side is the same as this side. So I need to rotate it and put it together. If I look closely, I notice that I have a parallelogram. Let's do the same thing with the obtuse triangle. There they are again, exactly the same. So I'm going to get this side to match up with this side. And again, I end up with a parallelogram. So for each of these, I could say that the original triangle is half of the area of the total parallelogram. Well, again, I know the formula for the area of a parallelogram. It is the same as a rectangle. It's base times height. But I also have to remember that the height of these triangles is not a side. It is a separate measurement. If I look at the acute triangle first, I'm going to call the bottom the base, and then the height is not one of the other sides, but it is a perpendicular line to the base. So it might be right here, going all the way to the highest point. And it's perpendicular, so I would call this h, the height. Sometimes you'll see it measured on the outside of the shape, but it has to go to the highest point. And if it's a right angle there, then we would call this the height. Notice that they're the same length. And I can do the same thing on the obtuse triangle. If I call the bottom here the base, the height would be from the base, a perpendicular line, all the way to the highest point. That would be my height, h, right there. I could also extend it out this way and measure right here to find the height, and that would be the same measurement. So, my area formula for any triangle is still 1/2 of base times height. The only difference is that the height is not one of the other sides. Remember, in a right triangle up here at the top, we just use these two sides because there's already a perpendicular line there, measuring the distance between the highest point and the base. With a acute triangle or obtuse triangle, we need to measure them differently because it is not one of the other sides. We have to draw a perpendicular line to the base to find the height.